So the warm-up question for today says, which has the strongest charge? And you see a diagram similar to the ones that we were looking at yesterday with two charges labeled Q1 and Q2. And we need to determine which one's the strongest charge, which one is positively charged, and which one is negatively charged. Those are your warm-up questions for today. So let's start with number one. Which one has the strongest charge, Q1 or Q2? Why do you say Q1? Yeah, the field lines are closer together. All right, so Q1 does have the stronger amount of charge because we have a higher density of field lines. All right, number two, which one is positively charged? What do we think? I hear Q2. Why Q2? Arrows are pointing away. All right, so again, we talked yesterday about the rules for drawing field lines. Arrows always point away from positive charges because those arrows show the force that would act on a positive charge. And positive charges would push other positive charges away. And so yes, the Q2 would be positively charged, and therefore Q1 would be your negatively charged particle. All right, guys, if you're still having conversations on the side, let's go ahead and quiet those so we can talk through what we're doing today. In just a minute, you're going to be opening up 1103 Transfer of Charge Sims. It is a Google form, and it's going to take you through some simulations. But before we do that, I'm going to talk first about a project that we have upcoming, so I do need your attention for that. And then I do want to mention, and it's listed here, that there is actually an entire Bill Nye the Science Guy episode in these slides, if you feel so inclined to watch it, that reviews the entire unit of electrostatics. It's on slide 35. We don't have the time to watch an entire episode of Bill Nye in class, but I put it in here in case it is something that would be of interest to you. I do have a couple follow-up questions on the warm-up before we get to the project. So here's my first follow-up question, then we have one more. The first one says Q1 has 4 times the magnitude of charge as Q2. Which free body diagram would show the interaction between them? A, B, C, or D? Well, first things first, I know that they're opposite charges. So I do know opposites attract, which means I do know that I should have arrows pointing toward one another, indicating that they are pulling together, which means that we can eliminate B and D right off the bat. So the question is, should those forces be the same, like in A, or should the force of Q1 on Q1 be greater? What do we think? They should be the same, like in A, because it is a force pair. Again, don't forget Newton's third law. For every action, there is an equal and opposite reaction, and that is going to apply to all of our forces, including our field forces like this one. So answer choice A would be what you'd select. My second little follow-up question here is a calculation. I figured that some of you, if you had any issues with the calculations yesterday, it was probably an issue with this. So I do suppose if you want to copy it down, you might want paper out for this. But there aren't any notes after it. But those of you that missed questions probably missed the calculations that asked you to solve for distance of separation, because that's the hardest thing to solve for when you're looking at that formula, because it's in the denominator and it's squared. So getting your algebra correct could be challenging if that is something that you struggle with. This one says Q1 has 4 times the magnitude of charge as Q2. If Q1 has a charge of negative 3.2 times 10 to the negative 5th coulombs, and it experiences a force of 3.7 newtons due to its interaction with Q2, how far apart are the two charges? So let's label some stuff. I know Q1, negative 3.2 times 10 to the negative 5. I'm going to write it like this because that's how I'm going to type it in my calculator. And then I have my other charge, which is 1/4 as much. Okay, because it says Q1 is 4 times, so Q2 is 1/4 as much. It is an opposite sign, so I went ahead and included that too. But I will need to divide that by 4 before I actually solve. The other number I know is my electric force, 3.7 newtons. All right, so when I go, again, I had to divide by 4 first, but when I go to plug in to my formula, you'll notice I did not bring the negative sign with me. Because as we talked about yesterday, when we solve for force, we're solving for a magnitude. Now this time they gave us the force, but they gave us the magnitude. If you try to plug a negative sign in here for this, you're going to end up with the problem as you get toward the end of your calculation, because you're going to end up trying to take the square root of a negative number. You don't want that. Again, always deal with the magnitudes only when you're doing this calculation. So even though it's negative 3.2 times 10 to the negative fifth, I just wrote it as 3.2 times 10 to the negative fifth, and I substituted everything in. The first thing I'm going to do is go ahead and multiply these terms to get just one value in my numerator. When I multiply my constant, 8.99 times 10 to the ninth, multiply it by 3.2 times 10 to the negative fifth and 8 times 10 to the negative sixth, I get that value right there, 2.30144. And so now I have something that looks a lot easier to solve, but it's still an issue for some of you who are struggling with the algebra. Guys, you cannot solve for that value for r when it's in the denominator of a fraction. So you need to get it out of the denominator, and we do that by multiplying both sides by r squared. So now you have 3.7 times r squared equals 2.30144. We're trying to solve for r, so we want to divide both sides by 3.7. When you type that in, you get this, 0.622, but again, that's r squared. One last step, take a square root. By the way, if you had forgotten to do what I said and forgotten to take that negative sign off, this is where you'd be running into problems, because you'd have the square root of negative 0.622, which you can't do. Okay, so again, just make sure you're not bringing the negative sign with you. When you take the square root, you get this, 0.79 meters. Again, that's the trickiest type of calculation that we could ask you to do, because we're asking you to solve for the denominator, and that denominator's been squared. So there's a lot of math in order to get it isolated and solved correctly. Does anybody have a question about this problem? Okay, again, you can go back and look through it again. If you had trouble with those in the assignment yesterday, that would probably be a good idea. As I said, before we get to today's assignment, I first want to talk about an upcoming assignment that we have for our next unit on circuits. Right now we're doing electrostatics, which are stationary or static charges, and the next unit we'll be talking about the flow of charge as these charges move through circuits, and your project will be to build a house, a scale model of a house in which you have to wire up light bulbs. And so that's your project that will actually start next week with the unit. Well, technically we're starting it today because we're talking about the project. But you are going to be working in a group of 3 to 4 people. And so you do need to figure out who it is you're working with, and that would be a good conversation for you to have today. If you're looking for information on the project, you can find it in the Unit 12 folder. So if you go into Schoology, sorry, I'm trying to figure out where I put my Unit 12 stuff. There it is. If you go into Schoology, the assignment inside Unit 12, you have this red folder, and it has these 3 things in it. Specifically, you'd want to open up the project information sheet because it has the details for your project. So if we take a look at what this sheet says, it says that I'm not going to read the whole thing, you guys can read it, but it says that you're building a house that must have at least 4 rooms. It can be 2 stories or 1 story. You have some options regarding how you actually construct it. But each of your rooms has to have at least 1 working light bulb, and they have to be powered by 2 different types of circuits. And I know you don't know what these circuits are yet because we haven't talked about it, but obviously before you build it, we will. But you have to have both a series circuit and a parallel circuit. However, there is an option for bonus points on this project if you choose, and it says right here optional, if you choose to instead build a combination circuit instead of your parallel circuit, you can get 5 bonus points. It makes your math a little bit harder, which is why it's worth bonus points. It also adds an extra light bulb, which means you can either have 2 bulbs in 1 room, or you can even build an entire 5th room to your house, up to you. You guys are responsible for bringing in your own materials. That's going to be shoe boxes, cardboard or foam board, foil, masking tape, whatever decorations you're going to use. And we'll be using old Christmas lights for the lights that you're going to be putting into your house. I'll provide you with 4 or 5 if you choose to do the bonus, but if you want any more than that, that's going to be on you to bring those in. If you have old Christmas lights, that works best. Again, there's a bunch of information in here that I'm skipping past, but if you keep looking, it goes over what you have to turn in, and some of the requirements. So we'll revisit this later on. But if you keep going, what I want you to see is there's a rubric down here, and you can tell that there is a group planning document which is due next week on the 26th. So that's the first thing that you're going to have to take care of. And no, you don't have to take care of it today, but you do need to make sure that you have some discussions with your group prior to that due date on the 26th, because the whole point of the planning document is so that you can figure out who's bringing in what materials, because you're going to need them the 27th or the following Monday. Just to give you time to figure out who's doing what. But again, here's your entire rubric. It says what's required of you for your series circuit, for your parallel circuit. I do want to point out that for this project, 20 of your points are entirely on you, because they have to do with your room design. Each person in your group is designing their own room. So if you do nothing and don't do yours and the rest of your group does theirs, well, they can get 100. Your highest grade is going to be an 80. Okay, so that is 20 points only affects you and nobody else, because everybody's got their own room to design. Now, the rest of it, of course, is a group effort, and those scores apply to everybody. But just a heads up, if you don't pull your weight or do your part, you're going to get a score that's up to 20 points lower than your neighbors. Or if you do all your stuff perfect and they don't, you'll be potentially 20 points higher than your group members. There are also bonus points available. I mentioned already that you can get some of these by building a combination circuit, and I know you don't know what that is yet. That's okay, but it is an option that every single person in the room can do 5 bonus points. There is an additional 5 bonus points for what Mr. Quigley and I decided to call Homeowners Association House of the Year, which basically means if we think that you have the most creative and best decorated house in the class period, you can get 5 bonus points. Obviously, that only goes to one group, but if we like your house the best, then you'll get an additional 5 points, which means you could get up to 110 on an RA grade, which is helpful. So anyway, I'm going to let you guys read through this at your leisure. I'm not going to read the whole thing to you. The group planning sheet is this document. Again, you'll find it in there. Only 1 per group needs to be turned in, but it has a spot for you to divide up all the tasks. You can work on that later. It also has a spot for you to designate what room you're making, because I don't want your house to have 4 kitchens and nothing else. That makes no sense. Okay, so it's up to you to discuss with your group how you want to handle that. So anyway, you will find that in Schoology, and you're welcome to start looking at it. It does tell you in the planning sheet to describe what type of house you're going to make. Here are 2 different styles that you can make. The multi-story house, usually it's made out of shoe boxes or something that are stacked, and you can have multiple stories. Something that looks like this, or you can build something that looks more like a floor plan. If you've ever looked at one, like overhead floor plan, it's basically a house without a roof. It's got walls and stuff, but it is going to be 3-dimensional in either case, and you are responsible for decorating a room and putting furniture in it and all that, and it says it in there. So anyway, again, look at it in more detail on your own. But for right now, what you're doing for the rest of the period is working on 1103, Transfer of Charge Sims. It's a Google form in Schoology. It does use the site Java Lab, which has been having difficulty loading every time I've opened it. And so if this site doesn't load, there are links in there that have video clips, which is why I mentioned that you might want to bring earbuds so that you can listen to the videos if the simulations aren't loading. I'm hoping they're loading, fingers crossed, but if not, hopefully you have earbuds. If not, then I would recommend just turning down the volume and watching it with a neighbor so that there's not 30 computers all playing sound at once. If you do finish early, I'd recommend looking at that Bill Nye video on the next slide, that's slide 35, or start talking about your electric house with your group. All right, guys, if you have any questions, let me know. Otherwise, I'm going to let you guys get to it. and get to work on 1103 transfer of charge Sims.